Hi, all. Good evening. We will be starting the session exactly at 6:30. Thank you for joining a little early. Please be on the meeting. We shall start the session exactly at 6:30. Hi, good evening, everyone. Again, thanks a lot for joining in. So we shall be starting the session sometime shortly, exactly at 6:30. So we will be briefing you on the details of specifically about opportunities for engineers in EV, and then also we'll discuss about how do you map yourself with the skill sets in the EV sector, and then I will also give you a run through on how do you generate your course certificates for this program, and that's it. So that's what we'll discuss for the today's topics. So again, thank you very much for everyone for being part of this meeting. We should be starting in a minute. So yeah, you might have not, if we might have not interacted with each other on the video call or on any of the communication, which could be face to face. By the way, this is Suraj on the other side who been handling the first 4 days of the session. And then it was continued by Krishna, who's a senior simulation engineer who takes care of modeling the various powertrain systems, and also he's currently working on design and development of driver assistance systems for automotive applications. It's quite a small team at Decibels Lab. We are about 9 members currently. Yeah, we work on ADAS, autonomous vehicles. We work on electric vehicles. We also specialize in embedded hardware design. So we are looking forward to come up with some products into an EV market apart from our training businesses that we handle day in, day out currently. So as a part of a product development journey, it gives us some leverage to be ahead in terms of technology, to educate and to share what we know and what we work on day in, day out. So yeah, this has been a series of lectures. I believe you might have enjoyed the lectures that I've delivered. So I'm here across today to also take some of your feedbacks on how this program would have been also improved. And be honest to share your feedbacks, please. And yeah, apart from it, we'll also share some of the interesting discussions on how you can explore your career, or possibly what skill sets that industry would ask you to have when you graduate, or else when you want to explore a specific sector-based career opportunities. Code 6:30, so we should be starting our discussions right away. So I have a small deck of presentations, which is not more than about 15 slides, but I'll run through quickly. The whole meeting will not take more than about, let's say, a maximum of 30 to 35 minutes, or if there is any QA or any interactions, maybe it's going slightly more than that. So by probably we expect to start close the meeting about 7:15 at max. It's cool. So let me just go offline onto the screen sharing. Thanks a lot, by the way, everyone who been joined here. So right. So yeah, on the topics of today, let's say we have close about 40 people. Awesome. So thanks a lot, everybody, for joining in again. Let's just get it started. So let's start out with the first topic, that's on mapping the skills to sector needs. So as a part of this presentation, I've listed some topics here. So one is on the traction cell and a pack. Other one is on the BMS algorithms, and then further on traction motor and motor controls, and then power electronics. Then also in the areas of vehicle testing and validation. So what are the kind of specific requirements in the industry? I might have already listed down here, so I will just go in deeper way that you can, gain some exposure to these areas. So specifically, if you want to work in the areas of cell, very fundamentally at the in depth of development of a cell, or selection of materials for the cell, or selection of a new or development of new materials for anode or cathode, or testing the characteristics of those materials and things like that. So you may be required to have an MTech or at least MSc in chemistry, or also explore PhD in chemistry or electrochemistry specifically, or you might have worked in similar. So you might be working on those similar areas. You might be having an exposure from similar of those areas. That if you would like to, explore any of the career opportunities, specifically in the cell development. But as such in India, so as we are majorly into application, I mean, there are some companies such as Log9, Loham. And also Exicom has recently, um, just a second, I might have lost my, yeah, sorry, there was a fluctuation of internet, so I just lost my internet connectivity. Let me just share back the screen. Right. So it may be quite difficult to find a large amount of opportunities, but though there are a lot of research going on for the cell development and for the areas such as um, I would say uh, material development and things like that. Definitely, a lot of people are trying to progress some good development to have fast charging technologies and stuff like that. So yeah, there is definitely a certain requirement for engineers to work in the areas of core of set development. But yeah, as such as the opportunities are quite limited because the number of companies which are working are also quite limited. So coming to the areas uh, of cell as an application, so there could be quite a lot of opportunities for a lot of engineers to work in the areas of uh, application as a cell. Let me just share back the screen and waiting to join. Sorry, just a second here. Just some. Yeah. So so you could find a lot of applications when you talk about certain job roles which is specific to the industry in terms of application. So in terms of applications, let's say it may be the areas of cell testing and characterization and cell selection for vehicle application, cell behavior modeling or pack modeling or pack level testing or battery pack design or battery pack thermal management system or in the areas of battery pack testing and homologation. So this is a specific opportunity that are quite largely available in the industry today. So what typically people are expecting is to have you the knowledge of using some of the testing equipments. Maybe you have test equipment, something like this, where you can actually keep the cell and you can call them as the cell cyclers, where you're able to use these components and make the cell to undergo um, realistic cyclic scenarios. So maybe it is also with respect to temperature. You can vary the temperature from minus 45 to like plus 60 degrees Celsius or 70 degrees Celsius, and see if the cell is big, if the cell is able to take the temperature, and how exactly the cell will behave in all these temperature conditions and stuff like that. So you can basically subject the cell to various this loading scenarios, and then you can check if the cell is able to perform better, or if you have a specific target requirements, and or if you have R&D requirement to see if the cell is really suitable for your application. You can definitely do all these activities, or you can also develop certain algorithms by collecting some data from this cell cyclers. So altogether, yeah, they would definitely demand you to have some skill sets to use this hardware. Maybe this would be a single rack, and Arbin would be the set of multiple racks that being displayed here, or a temperature chamber. And now you know that you have a data from the cell. So what exactly you do with the data that has been taken by the cell cyclers? So you should know how to use the data and make a meaningful information from that, and that would require you to have some good exposure to definitely the cell chemistry, and cell behavior, and predicting what exactly happens with respect to these cell graphs that are coming out of this test equipments. So that means definitely you should have some knowledge of electrochemistry and the cell behaviors and loading conditions also to conduct the cell at different testing scenarios, because your test cases should be very relevant to your realistic test cases too. So all these are the part and parcel of cell testing and characterization, or even to a level where to choose a specific cell for a vehicle application. So when you talk about selecting a cell for a very specific application, we should know where the cell, what kind of segment the vehicle is for. What is its charging behavior, what is its discharging behavior, and what is the average temperature exposure scenarios, and the pattern of driving. A lot of these things will come into a picture when you're selecting a cell, because the one single cell is not suitable for all the different applications. So you should be quite cautious on all the scenarios. So then also people are expecting you to have the exposure to cell modeling. Typically, we would use tools like MATLAB, or you could use tools like Cosmol, depending upon applications that are in the industry or what software that the industry has. But at least if you have an approach to model the cell, that is really, really important, because there are various different approaches of modeling the cell. Maybe it's like an electrochemical method or physics-based approach, or various different similar approaches that are available in the current scope of work. So you should know how you can actually model these cells, and using tools like MATLAB or any other tools. And what are different methodologies where you could do something using an Thevenin circuit or an equivalent circuit based model, or you could use something like an Kalman filter. So people would expect you to have Kalman filters knowledge. And obviously there are specific to a cell, like you talk about a cell balancing algorithms, or SOH algorithms and things like that. So it's all about knowledge of cell, and also you should have some knowledge to know about Kalman filters or extended Kalman filters or particle-based Kalman filters and stuff like that. So yeah, that's majorly the scope. So it means it's 1D modeling. So that's a good exposure to have for the design of cell selection and parameters specifically on the lithium ion as an application to the industry. When you talk about the applications such as pack modeling, and which is also majorly in the 3D, which is basically using CAD softwares, and that comes in the packaging design. And also there are approaches where you could think about CFD and also CA applications. You could use tools like Altair or tools of Answers, or there are new tools available in the market specifically for a battery thermal analysis. You can also use some of those tools and skill sets. So that's majorly a part of it. And then we come to homologation and testing. Once the battery pack is manufactured, so there are specific rules that are in India, and also if you're working globally in any other country, so you would have rules specific to the countries that you have to undergo homologations. So all those homologations are a part and parcel of the journey as the battery engineer or a pack designer, and things like that. So I listed some of the job roles, and on the other side, the skill sets that is required. Now, this is not something very uncommon, that now if the industry guys are asking some job roles, they'll mention you all the possible skill sets that they want to ask. Now your job role may be very specific, but they would be like, if there is a guy who want to be hired for a battery management system, they would want you to also knowledge of electric, components of electrical subsystems, their behaviors, and knowledge of embedded hardware design, knowledge of the standards for embedded hardware, and people will be also asking some skill sets on the cell chemistries, the materials for the cells. They don't have to lose anything, right? If they just list out everything that is possibly in the world of BMS development, and they just want everything to be there as a skill sets with you. And it's quite impossible for sure to have all those skill sets, because it is not like realistically feasible. So with that as a scenario, they would also compromise at one day, because they understand they can't find an engineer with all the skill sets, right? So if you're able to match about like 50% or 60%, it's just quite more than enough for you to apply for any of those job roles. So as I mentioned, specifically on a cell behavior prediction modeling, and also on the battery pack design in terms of a sizing without using a 1D simulation software. So then some of these areas where you use a specific hardwares, and then on the BMS side of it, so typically it's all about algorithms for the BMS, and also some areas of embedded hardware design where you can actually do a PCB design and write your own algorithms for SOC estimation and any other estimations as such. So as a fresher, if you're asking me, it's good to have embedded hardware design because you may not be actually going to work in hardware design. Let's say you want to work in BMS, right? So you have to be very specific. You want to work as a BMS algorithm engineer or a BMS hardware engineer. But though you want to be a BMS software engineer or a BMS hardware engineer, it's good to know to a certain extent in both the areas, because the way you think about a system would completely vary when you know the complete system to a level of understanding. Because if you're an algorithm engineer, you don't know the hardware where it is actually going to be implemented. Your scope of thinking would possibly be limited at certain areas. It's good to also have a knowledge of PCB. It's very rare nowadays. Colleges doesn't have this in syllabus, but they think it is more like a basic job. But it's quite an important thing that you also should have a good understanding of PCB design, component selection, and see, for example, if you're designing an algorithm for a BMS, where you want the data of a voltage of a cell, you also want current of the battery pack. So if you're selecting a sensor, you should also know when you're writing an algorithm, what is the error percentage of that sensor that you're getting the values from. And when this sensor can read an erratic values, that is basically the hardware, right? So when you have the exposure of hands-on, again, not theoretically, I've built a BMS and write your algorithms, and when you see the data coming in correct, when you tune those algorithms, and then you mean that you have a practical understanding of where you're actually getting this data from. Because if you want to measure any SOC or SOH or anything, you want data from all these sensors, right? So these sensors reads the value, and there are a lot of fluctuations when they read a value. So when you have a practical exposure to hardware, you could actually write your algorithm much better way. But I'm sure you cannot be an expert in both the areas. Maybe some people are, but at least to a definite extent, for the 5 years of experience to a 4 years of experience, it's quite difficult to have a very in-depth exposure. So in that scenarios, definitely you can have a fair advantage, competitive advantage when you know both the areas of expertise. So I think I've already driven you guys through some of these presentations, but I'm trying to kind of collect them and put them at a one single shot. So when you talk about specifically on motors and controls, so a lot of electromagnetics for the motors will come into a picture. And when we talk about motors, it's not only electromagnetics, it's definitely materials that are part of motors. There's a lot of extensive research in the areas of motor materials, the design of motors, and specifically thermals. And on top of it, a lot of electromagnetics and then simulations as a part of it. And then compliances to EMI, EMC regulations. So once the motor has been developed practically, so you would go for a motor testing. So I might have also demonstrate some of the images for the motor testing, and definitely the control algorithms, and typically on the embedded programming languages, specifically on embedded C, and then definitely on the model in loop, software in loop, hardware in loop testing, and obviously the controller testing and validation. So functional safety are a definite requirement for any of the automotive sectors. And typically, if you're an entry position, they will not expect you to have like Kenoi or Canope or specific tools from Vector. They're largely used in any of the hill testing or real-time data collection. So and further, if you're a fresher, yeah, it's not that very mandatory that you have the skill sets, but yeah, definitely if you're about like 4 5 years of experience and you want to work on product development, so definitely guys would expect you to have those skill sets on maybe like tools like DSpace or NI or AI tools from Vector, or also there are tools that are being used for project management and documentations and stuff like that. So there is some expectation if you have about 4 5 years of experience and then you want to switch a job. But if you're a fresher, you have some leverage of not having those skill sets. So where do you begin? So you could just play around with some of the development tools like this. So where you can buy some of these tools. They're not cheaper, by the way. So at Decibels Lab, we have all this hardware equipment so that I can actually come down and learn and get an exposure from the trainers that how this hardware is and what components of this hardware functions in this way. What is motor controls and what kind of algorithms are there, so what exactly we control in the motor, and what exactly we tune to make the motor to achieve certain performances and stuff like that, right? So that is all part of the motor controls. And then you can also work on embedded hardware design, where you can design your own VM, so your own motor controls. You can actually run those motors using these motor controls, which comprehensively give you a very fair exposure to understand the possibilities of motor hardware, motor controller hardware, and also motor controller software. So then definitely as a part of MATLAB, so or any other tool benches that you can use, so you can definitely do motor control algorithms as I was described in that day, which is maybe simple speed and torque control, or field orientation control, field weakening control, or direct torque control approaches. It's fairly enough if you have all these skill sets with 0 to 1 year of experience. If you're a student who are still studying, and if you have all these solid skills before you graduate, I think you have equivalent exposure to 2 years that the guy is working in the industry. Because somebody maybe working in industry, they have very limited exposure to one area. When you learn all these things and when you enter the industry, that you have overall scope of the product development, from motors, controllers, BMS, algorithms, cell, its behavior, and stuff like that. So certainly in power electronics, that comes in the areas of chargers, and then in the DC-DC converters, or it's on the buck side or a boost side as a part of it for your auxiliary loads. So and then on the last side, I might have not exposed you on this, specifically on testing, data acquisition, and calibration. There's a lot of good scope for engineers because it's not just about developing everything using software and making individual components. At the end of the day, all of them have to integrate and function in synchrony. The word synchrony is very important. That they have to have proper balance between each other, right? That is being a scenario. You need to test the vehicle extensively at various different scenarios to see how it performs, how it holds up. It's to meet the required targets, and also to make sure that the things that you have done, as in calibration, always stays positive at any given possible scenarios, right? So a simple example, like if you're going on an uphill, if a vehicle is not able to give you the performance output as it is expected when you press an accelerator, it is definitely a bad calibration, right? Or if you are standing at a traffic light and it is red now, and it comes to green and you press an accelerator, because it's electric, it is having a lot of torque. If it moves very quick, you may meet with an accident which is dying in front of you. So all these calibration scenarios will come into a picture where the calibration engineer has to take care of, tuning those algorithms to meet the realistic scenarios. Or maybe if you take a regenerative braking, you may have done a lot of simulation, but in the realistic scenarios, the regenerative braking value is going to be very drastic in nature. So you would have to definitely collect all this data and then come back to your desk and visualize and make it as a possible tunes that you could put back in the controllers or any of other components that comes as a part of the vehicle, that the vehicle works in synchrony. Okay, right? So that's pretty much from my side. That has been I've been thinking to deliver today, and as a part of this discussion, so our team has planned to provide some options that you could avail to learn some of these programs at Decibel Lab. So I would be very happy to just share you across those details. In the meantime, if you have any questions across, so kindly put the questions in the chat box. Great. So there is one question from Jayesh that has been sent directly to me. I'm fresher mechanical engineer to be in EV domain, but together also I want to master in either CAE or FEA and CFD. Okay, but I'm very confused between FEA and CFD means which will add more potential in contrast with EV skills. Fantastic. So, Jayesh, to personally suggest you, so the CAE, FEA, as in a very large term. So the CAE, computer engineering, and CFD, they're two different things, right? Which I mentioned in the first very beginning. If you talk about CAE, so you could work in the areas of, let's say, if the motor has been assembled, when it produces an output, right, it is having a momentum. That means it creates the load on the mounting points, or because there is a lot of uh, vibrations on the road, or there is any scenarios where there is a load on the mounting of the motor, right? So all those loads can actually impact the motor, that the motor can possibly motor housing can possibly fail, right? So what is the job of a FEA engineer or a CFD engineer is basically, he can perform the meshing, and then you would be able to actually analyze all the loads, and then he could possibly design a very well designed motor mountings. But when you talk about a CFD, it's more about to study the thermal behavior of the motor. What is the amount of temperature that has been generated at the motor? If I have this cooling system, how much the temperature can be reduced, right? And studying that part of it is more about CFD, and designing the motor that it can take a loading conditions, that could be your CAE requirements, right? So both are very largely two different areas, all right? So you can be expertised in both, but I would suggest you have to choose what you want to be as a part of your career. You want to work in CAE or you want to work in CFD. If you want to work in CFD, you can definitely explore some upskilling opportunities in CFD. And if you want to work in CAE, you can also definitely explore your career in CAE. You can also talk about the battery FEA, where you can talk about whether the battery can take up the load at any given scenario. How does it holds up to the loading conditions and stuff like that. So it could be also NVH studies where you can check how does the battery holds up for various loading scenarios. There's something similar in various areas which you can always explore. Uh, we don't have any programs on CAE or CFD currently as right now, but we also have some programs that is using 1D modeling or analysis of HVAC systems, that is also part of thermal management. We also have programs that are relevant to that, are like battery cooling and motor cooling, but they're into 1D modeling. All right. So if you're interested in 1D modeling, we can definitely help you. But if it is in 3D, we don't have programs right now. Great. So let me just introduce you something that we've been planning to offer for the participants of the foundation course. So the participants, whoever have participated in the foundation course at SMU's lab for last 5 days of the program. So we have some of the programs that are currently available on a discounted price for all of you. So specifically to start with the first program, which is on micro specialization in PV, powertrain, electronics, and component modeling and motor control algorithms. So that course has about close to 8+ projects where you'll be actually able to develop various type of converter circuits, inverter circuits, modeling the DC motor, and also modeling and algorithms for a BLDC motor. So it's an amazing course that has been helped many engineers to fetch a career in the areas of electronics and electrical engineering, specifically on power electronics as in together. So also we have a program micro specialization on BEV systems and powertrain engineering, which is a very much important program for a mechanical engineer or automotive engineers, where you can actually develop a whole vehicle. Like we have projects on Ather 450, Nissan Leaf on Formula Student race car, where you'll be able to actually build this powertrain in a MATLAB software, where you run a simulation and study their behavior with respect to motor sizing, battery sizing. It is an exact replica of what an industry does, or what any of the Tata Motors does, or Bosch does, or Continental does at their company. We would be also able to learn similar things across this course. Then for somebody who have been asking me that, do you have an advanced program on batteries? Yes, this program offers you a very comprehensive exposure to two different things. One is on cell testing and characterization, which is a very fundamental and important part of the batteries. So one is on cell testing and characterization. So where you will be able to understand the behavior of a cell, and where Mr. Venu, who is the CTO of Decibels Lab, who has a hands-on exposure to use airborne equipments at his university in KTH, Sweden. He has created this complete program. So where we explain them the complete fundamental behavior of a cell, and also the areas where we can explain you what kind of tests are conducted, how these tests are conducted, what is the importance of this test, how do you collect the test data, and how you are also able to utilize the test data to do a modeling of cell and algorithms. Then in the module 2, we are covering up on the areas of modeling of battery management algorithms and also BMS algorithms. For a lithium-ion cell, using an equivalent circuit-based approach that is on a Thevenin approach of modeling. So where you'll be able to learn a very in-depth exposure of uh, equivalent circuit modeling, and also on SOC estimation using Coulomb counting and other methodologies as well. So if somebody is interested very much to explore specifically in the areas of algorithms, we also have another program where we talk about Kalman filters, using Kalman filters where you'll be able to do an SOC estimation. If you want to explore more on this program, you can go to the programs in EV. So we have this program called Level 3, that is extended Kalman filter based SOC estimation. All right. This is a fantastic program. A lot of people from industry, even many people from abroad, have taken part in this program. But if you want to learn this program, you should complete your level 1 and level 2. Basically, level 2 is cell testing and characterization of algorithms, lithium cell and BMS algorithms. So this is something I would suggest for if somebody is interested in algorithms. If somebody is interested to begin with EV as a mechanical engineer, you can definitely start with micro specialization in BEV systems and powertrain engineering. That would be the fantastic beginning for any engineers in the mechanical sector. And if you're very much focused to explore in detail of EV, we also have some advanced programs in level 3, which is specifically for a mechanical engineer on the areas of thermal systems, specifically an HVAC system modeling, and battery cooling and motor cooling. If you're going from electrical engineering, after you complete our level 2 courses, we have a very structured learning approach where you could start with level 1, which lays you the proper foundation to understand the systems and technologies that are present in EV. We have done with latest to latest, that is Tesla's latest vehicle model, how their thermal management systems are using heat pump based concepts, so that you understand all the subsystems that are present in EV in depth. Then you come to level 2, where you practically model, about all the systems, because theoretically anybody can teach you, and teaching you with using MATLAB as how foreign universities does in abroad, like in Europe or in US. So we are teaching the same way. And a lot of people teach it using Simscape, which is the dumbest way of teaching any engineering things, because everything is pre-built inside a Simscape model. So you just have to drag and drop the model and just connect some lines, and then you have a model. I think a lot of fantastic engineers who doesn't know how to use Simulink has taught a lot of videos on Simscape, which is basically doesn't teach you anything better. But using these programs, they're trying to teach you with Simulink. It's purely in Simulink. So you write an equation, you convert that equation into a model. So that is an approach what everybody does, not using a SimScape. That's the large difference between what somebody else courses along with Decibel's programs. So it is what exactly the way industry does, because we've been extensively working to create some products, and that is in an alignment. We're also creating these courses together for you, and then you can migrate to level 3. So the micro specializations are something where you have clubbed some programs that it becomes like an combination of a couple of programs that is aligned to specific areas of engineering. So somebody asked a question that if they want to explore something in the areas of power electronics component modeling, and yeah, so surely. So as a part of the power electronic component modeling, we are using two softwares. One is Scilab, other one is MATLAB Simulink. So it's quite a good opportunity for you to learn both the softwares and model them using both of the softwares. So on the part of modeling, let's start with, yeah. So if you talk about the power electronics as a first initial figures, so where we are working on modeling the EV chargers and modeling inverter circuits and buck converters, boost converters, and also modeling the DC motors. This is all using 1D based approach where we use similar to MATLAB tools like Scilab. And in Scilab, we call it an XCOS, similar to Simulink. So using those toolboxes. And then further on, where you will be able to gain a deeper understanding of motor control logics and how exactly the motor will be controlled by switching the MOSFETs or to the driver circuits and stuff like that. So where you can actually build all those approach of controls and approach of tuning those controls, such as PIDs, in the motor controls as a part of it. By the end of this course, you will have a fair understanding of what is actually the motor controls is, and what are the methodologies of motor controls, and how you can actually model the motor in a physics-based approach using tools like Simulink. This is a fair good understanding for any electrical engineer to have. So these are the micro specializations that we currently offer. So under these micro specializations, I think this is still this upcoming Friday, I believe. You can avail this discount of 40% if anybody is interested to learn and take part in this program. So the coupon code is DBEV. So basically, all these programs which are currently available here are offered at the cost of 40% discount. And then we have two more programs. If anybody is beginning, you're not very much focused to pursue your future in EV, but you're an engineer, you're working in automotive sector, but you want to know about EV. You're very, very beginning at this stage right now, and you want to understand what is EV is. So you could just definitely start with any of these two programs, which is EV Technology Certification Program, which is an extended program of what I've delivered in last week, where we have taken more in-depth explanation of all the subsystems and also auxiliary systems such as HVAC system, cooling systems, and a lot of other systems in depth. So that would be a fantastic course to begin with. And specifically on test and thermal management system, it is slightly a deeper program where you need to have an understanding of existing systems that are present in EV. So we try to develop a content that everybody can learn. But yeah, you have to have some exposure to fundamentals of thermodynamics, as you might have studied in college, to understand the part of test and thermal management system. But it's definitely a worth program to understand what kind of systems that are present in EV, how complicated an EV system is, and how actually it is so difficult to design one single system that has heat pump based systems. It's a fantastic program. It's just like an understanding and engineering marvel what Tesla has done. So any of this program, if you're happy to learn and jump into it, our team will send you a link to your email ID and a coupon code. So it's only limited to the participants who have taken part in these programs. You can look forward to explore some of these programs as per your interest. Great. So that's, I think, pretty much from my side. So if you have any questions out here, I will be happy to answer. Distinction between micro specialization 1 and 2. I didn't understand. You mean that micro specialization on power electronics, on micro specialization in BEV? Micro specialization in power electronics and motor control algorithm doesn't talk about uh, motor sizing and battery sizing, and the micro specialization on powertrain sizing will talk more about actually on the component sizing optimization. Example, like if you want to build a bike, and how do you size your motor? How do you size your battery? Right? That is exactly what is taught using MATLAB and Simulink, like the way how industry does in that program. Great. So, all right. So, if you have any questions, floor is open for QA. And also, I will be very glad if you can share some of your feedbacks. So, we are enabling an option where you can actually unmute and you can share your feedbacks. We request you kindly share one by one so it's easy for us to manage. I'm sure we don't have much time, and I'm just left with one thing that's explaining about how do you get a certificate. So we'll be quite happy to know as a trainer, how was the session, how were the sessions in the last 5 days, and if you have any specific learning expectations and anything of that sort. So we are quite happy to hear from you. So over to you, so to share any of your feedbacks. So anybody who's on the meeting, if you're happy to share any of your feedbacks. Yep. There are about 57 people. I think you have an option to unmute. So you just can click on unmute and you can also share. Okay, any prerequisite software programs, what software is required for this guy? Anything at Decibels Lab is always start from fundamentals, like from scratch. If you have no background of using software, it's totally fine. So we could help you out to learn that and then progress yourself to get into a hands-on with domain instances. So it's not a requirement that you need to know MATLAB or things like that. It is taught in the course itself, the due time. So yeah, that's right, Swagar. So the things that are shared across the screen, let me just reshare it back to you again. So all of them are actually all the micro specialization, 3 micro specializations which we're currently offering does valid for the discount, which is 40%, which has been offered for the fundamental course participants. Great. So any other questions from anyone? Great. Thank you. So it was a good learning exposure. Very happy to hear that. Awesome. So any limited validity? All right. So the courses which are micro specializations have validity of 120 days. It's about 4 months, which should be quite a lot of time to definitely finish up the learning content. And if you get any doubts, you have mentors whom you can interact with, and they will be very happy to give you suggestions or instructions to address any of your queries at any time. All right, so just the last call. If you have anyone interested to share your inputs and feedbacks on the voice, so we'll be quite happy to hear from you. Just a sense of satisfaction for putting in efforts to know how was this 5 days of the class as well. So cool. So I just lost somebody's asked. So this is all the programs that are under these specialization. Basically, these 5 programs are available to include the 40% discount that we are offering. Great. So at last, the call for anyone who is interested to share your feedbacks. Yeah, that's what I was supposed to explain regarding how do you get a certificate. Okay, great. So thank you very much, everyone. And the final step is about how you get certificates. So the first and important thing is we have added a new course to your account. All right. So that course has the same name, but it is having a one small dot in the end, which you see on the left-hand side, so which is right here. But that's the only difference. Basically, this course has all the recorded video lectures from day 1 to day 5. So you're ensured to actually complete all the lectures. And then you have the quiz, which is here. So we request you to take part in a 10 marks quiz. So minimum scoring is 80. That means you can only take 2 questions wrong. So that's the minimum passing marks for the quiz. So you have to complete this, and then there's a small feedback form that you have to just fill. And then at the last, there is an instructions that will tell you that if you have filled your names incorrectly when you're enrolling for the program or creating your account in Decibels Lab, so we request you to actually go to your account, all right, and make the correct naming. Because if you go to your My account and then just check if your names are correct on your account, which is mentioned something like this here for my account. So it should be a correct name, because if your name is incorrect here, the certificate will come in the exact same way, and there is no possibility that we can edit the certificate. So just do ensure that your name is correctly mentioned in your account, and then only generate your certificate. That is the instruction also mentioned here. When you auto-complete this course by 100%, you will receive a digital certificate automatically. That certificate can be always downloaded as a PDF or can be also accessed by going to the My account and under the sections of certificates. That certificates will be available with you for a lifetime as an access, even though the courses are going to expire. So you just have 4 days that to generate your certificates. Sorry, 3 days to generate your certificate. So you have to complete your course within that time and generate your certificate. If you do not generate your certificate, then you won't be able to generate your certificate anymore after 3 days. So we request you to generate a certificate within that 3 days. So when you generate a certificate, you get something like this. This is another program where it is a larger program for powertrain modeling. So we mentioned all the projects that we have completed. But right now, this course didn't have any projects as a part of it. So it will have a look something like this, which you can actually share on your LinkedIn, or you can copy this link. You can put on any of your resumes also, or you can directly share the certificate on the LinkedIn. And when you share your certificate on the LinkedIn, we request you to kindly mention Decibels Lab. So at least we get to know that you're a participant of this course. And we manage our LinkedIn account with the name of Decibels Lab. And I also have my account if you are happy to connect for any of the reasons in future. So we can definitely connect each other on here. So we manage our account with Decibels Lab. So if you have anything, that just tag us out, and then tag any of your trainers if you're enjoying the learning across there. And that's it. So you get to generate your certificate, and then you're good to go for any of the further learning. So fantastic. That's pretty much from my side. As planned, it is 7:16 right now. So anything else as a question you have from your side? So we'll be very happy to understand. Cool. So how long the course is access is valid, and also course consists of pre-recorded videos. Yeah. So the access for the course for MicroMasters is 4 months, and yes, everything is available in the recorded format, so you can self-learn according to your own time schedules. But anytime if you get a doubt or queries, so we are very happy to help you. So you could just get in touch with the mentor. The mentor would be very happy to help you in terms of any of the queries and questions. Right. So awesome. So if you guys are very much serious plans to explore your career in EV, we have opened up some programs. We call them as master classes. If anybody is interested, we just opened up for the master class was already there, which was basically on EV. So we also opened up some more master classes on embedded hardware design that is specifically for an electrical engineers and electronics engineers. We also have opened up advanced driver assistance system software engineering and also autonomous vehicle algorithm engineering. So, which are basically a very industry-driven, industry-oriented programs where we are promising a 100% placement I bet nobody does 100% placement promise. That they tell it's a placement assistance that if you do not get placed, they won't possibly bother about your placement. So, but at Placebos Lab, we are not taking too many people. We're just taking 5 people for a batch. So, if you have an interest to explore any of your master classes, these are the programs that are currently available on our platform, where it's about an 8 months long program where we are ensuring you that you get a placement within the 8 months. If not, you're getting placed, we also pay you a stipend and help you to learn and still stay at the civil staff, cover your expenses, and keep taking part in interviews that until you get selected. Great. So that's pretty much because somebody asked me about it. All right. When will the day 5 videos be uploaded? Right now, that video is not uploaded on YouTube because the recordings of the videos are about 10 minutes late. The first part of the video is slightly missing, but we have still kept those videos on our LMS. I think you might have not visited the LMS. Just if you visit our LMS, we have a day 5 motor sizing video that has been updated on our LMS, which is here. All you have to do is just log into your LMS, your account, and just go to the course. So we have the trainer who is explained on the day 5, which is about 130 minutes, I believe. Yeah. So yeah, it's close about 130 minutes lesson. So where Krishna has delivered the session altogether.
Yeah.
So yeah, if you have not checked it out, so do check it out. It is available on our LMS. We are expecting to recast this session on YouTube, I think on this weekend. If you want to attend the session on the weekend on our YouTube channel, it's definitely open
so
for learning.
Further, we'll calculate.
Right. So, okay, how many days you can generate? So you just have 3 days. Within 3 days, you are supposed to.
This session will be uploaded in YouTube.
Basically,
once we complete the session, we'll upload, and the certification will be issued, and we'll let
how many questions are available
when, about the certification. And motor speed.
Thank you very much, Varun, for your appreciation. Very happy that you have enjoyed the learning at the Civil Lab. We're happy to know that
motor speed is equal
the time that you
gear ratio
spent
into
has
wheel
been
speed. Okay.
Useful.
Wheel speed we have already calculated here.
Thank you very much again, and thank you very much, everyone. And
wheel speed.
If you have any learning
here
interests,
you
can get in touch with us. We will be very happy to help you.
And
so you can reach us for any of your learning inquiries.
And I will add a multiplication sign. And then
these two numbers,
I'll calculate the gear ratio.
Of our site.
Gear ratio will be like 7.8.
Help you out in learning things to explore your career in EV.
It will
if anybody who is planning for masters in abroad on EV, get in touch with us. We have helped many students to
for the wheel speed. I don't need
get a very good universities and help them to transition much better.
Try to
start their masters in abroad. Specifically in the areas of automotive too. Or in EV too. So if you're interested, you can get in touch with us. So finally, thank you very much, everyone, for providing your efforts and to learn about EV and to take part in the program.
We'll calculate. So we know
and I wish you all the
and
best
the speed value, right? So we'll calculate the motor power now.
Take care, everyone. Thank you very much.
Motor power.
Good night to all of you.
Motor power, we know the equation, right? What is the equation for the motor power?